You hear the name everywhere. I mean, it is in business journals. It is all over social media. It's just constantly in the news cycle.
Oh, yeah, absolutely everywhere.
Right. Palantir is arguably one of the most discussed companies in the world right now. But if you walk into a corporate boardroom or just ask a random person on the street and say, okay, but what does Palantir actually do? You're almost guaranteed to just hit a wall. You just get blank stares.
Or, you get those whispered, slightly conspiratorial answers.
Right, exactly.
People will tell you, oh, they build software for spies, or they track things for the government, or, I don't know, it's some kind of black box surveillance machine. It is a bizarre paradox.
It really is.
Like, the brand awareness is massive, yet the actual mechanical understanding of what their product is near zero.
Yeah, and our mission today is to cut through all of that noise. We are going to drop the spy novel hype and figure out exactly how this technology works.
Sounds good.
And to do that, we have to start with the origin story because, well, it completely defies the traditional Silicon Valley template.
Okay, how so?
So we go back to 2003. Peter Thiel, who, famously co-founded PayPal, starts this new venture. And he brings in a guy named Alex Karp to be the CEO. Now, Alex Karp is not an engineer.
Okay.
He is not a computer scientist. He actually holds a PhD in philosophy.
Wait. A philosopher?
Yeah.
Running a data analytics company?
Yep.
I mean, that makes absolutely no sense on paper. You expect the founder of a hardcore tech company to be someone who, I don't know, spent their 20s writing code in a basement? Not someone debating abstract concepts of reality?
I know. It sounds totally counterintuitive until you understand what Palantir is actually trying to build.
Okay, what are they building?
They aren't just building a traditional app. They are building systems that construct truth out of chaotic information.
Here's tried truth.
Yeah. When your core problem is figuring out how to architect knowledge-like, how to take completely fragmented pieces of data and turn them into a singular, undeniable reality, having a philosopher at the helm suddenly becomes a massive asset.
Huh. Even the name they chose kind of signals that ambition. Palantir is a direct reference to the Lord of the Rings, right?
Yes, it is.
Like the magical seeing stones that let the user see across vast distances and reveal hidden truths.
That is exactly where the name comes from. They literally set out to build a digital seeing stone. But the foundational technology for this seeing stone didn't come out of some top-secret government lab.
Oh, really? Where did it come from?
It came directly from PayPal's fraud detection engine.
See, I have always struggled with that leap. Yeah, because PayPal is an e-commerce company processing online transactions. How does stopping someone from, buying a television with a stolen credit card translate into the kind of software that intelligence agencies use for counterterrorism?
It seems crazy, right?
They seem like totally unrelated fields.
Well, it is entirely about the underlying math. Let's look at how fraud actually works. A sophisticated fraud ring doesn't just use one stolen credit card.
Right, they use hundreds of them.
Exactly, but they leave digital footprints. Maybe 50 different accounts are routing money through the exact same IP address. Or, they are all shipping to slightly different variations of the same physical address in a specific city.
So they're basically trying to blend in with millions of normal, everyday transactions.
Yes, and traditional software would just look at an isolated transaction and ask, does this password match? If yes, it goes through.
Which totally misses the bigger picture.
Exactly.
Yeah.
PayPal realized that to stop fraud, you cannot look at isolated events. You have to map the network. You have to look at the relationships between all the data points.
Oh, okay.
And once Peter Thiel saw how effective this was, he had a massive realization following the events of 9/11. He looked at the intelligence community and saw that they were facing the exact same structural problem.
Because a terror network operates the exact same way. Bad actors hiding their connections, attempting to blend into normal everyday activities.
Yes, exactly. From a pure data perspective, a financial fraud ring and a terror cell look remarkably similar. You're just looking for hidden nodes.
Okay, that makes sense.
Like a single burner phone record means nothing. A single wire transfer means nothing. A single flight manifest means nothing.
Right, on their own, they're just random data points.
But when you map the relationships, when you show that, oh, the burner phone called a number associated with the wire transfer, which was used by someone on that specific flight, suddenly the invisible network becomes visible.
Oh, wow. Okay. So the CIA realizes the value of this network mapping approach, and they become an early investor.
Yep, exactly.
And for years, Palantir essentially goes dark, right? Like, they operate with no public marketing, no major press releases, just quietly building software inside these classified environments.
Which is exactly why the mystique around them grew so large.
Right.
But, fast forward to today, and Palantir is operating in grocery stores, hospitals, and manufacturing plants.
Which is a huge jump.
It is. So how do we get from secret intelligence networks to civilian business? It all comes down to solving a universal everyday nightmare.
Which is?
The messy data problem.
Okay, wait. I feel like every single tech company claims to solve the messy data problem.
Oh, they definitely do.
But why is it so notoriously hard to fix? Like, why can't a company's databases just be programmed to talk to each other?
Because they speak entirely different languages. Let's look at a large, modern corporation. They might have a human resources system built back in 2015.
Okay.
A supply chain database built in 1999. And then a sales platform they just bought last year.
Right, a total Frankenstein situation.
Exactly. Now, if you want to know how a specific shipping delay will impact a specific customer's order, you need those systems to communicate.
And usually the IT department solution is to try and build an application programming interface, right? An API to bridge them.
Yeah, but building APIs between 50 different legacy systems is like trying to manually wire a telephone switchboard for 1 million people.
Wow, okay, yeah, that sounds terrible.
It is fragile, it breaks constantly, and it takes literally years. So instead of trying to force these different databases to talk to each other directly, Palantir acts like a universal translator at the United Nations.
Walk me through that analogy. How does a universal translator replace building APIs?
Okay, imagine you have delegates from 50 different countries. The traditional software approach is trying to teach the French delegate to speak Japanese, and then teaching the Japanese delegate to speak Swahili.
Which is basically impossible.
Well, it's totally impossible.
Yeah.
Palantir comes in and says, hey, everyone stop trying to learn each other's languages. Just speak your native language into this earpiece.
Oh, I see.
Palantir takes all that raw, messy data from all those different systems and translates it into a single unified ontology.
An ontology, so like a digital twin of the actual business.
Yes, exactly. In the Palantir system, a product isn't just a row on a spreadsheet in the sales department.
Right.
It becomes a fully fleshed out digital object that holds the sales data, the supply chain data, and the manufacturing data all at once.
Yeah. And once you have that unified digital twin, you can just layer artificial intelligence on top of it.
You got it. And you can simply ask the system complex questions and get instant coherent answers.
Because the AI isn't trying to search 50 different disconnected databases. It is just looking at the perfectly translated, unified digital twin.
Precisely. Now, to handle different types of organizations, Palantir has packaged this core translation and mapping capability into 3 distinct platforms.
Okay.
And the flow of these 3 platforms takes us from the absolute extreme of the battlefield all the way to the modern corporate office.
Wow. Okay. Let's start with the extreme. What is the first platform?
So platform number 1 is called Gotham. This is the platform built for defense, intelligence, and government agencies.
The spy stuff.
The spy stuff. Gotham is designed to ingest highly sensitive data from completely different sensory environments. We're talking live satellite feeds, drone video footage, ground trip communications, radar telemetry, and it fuses them into a single real-time operating picture.
But, wait, how is that fundamentally different from the dashboards the military has always used? I imagine generals have always had screens showing where their assets are.
That's a great question. A traditional dashboard just displays data streams side by side.
Okay.
You might have one screen showing a map, another screen showing a video feed, and literally a radio on the desk. The human operator still has to mentally connect the dots.
Oh, so they have to look at the drone feed, look back at the map, and figure out if the truck they are seeing on video is the exact same truck reported by ground troops an hour ago.
Exactly.
Which is an insane amount of cognitive load in a high-stress environment.
It is entirely overwhelming. Gotham removes that cognitive load. It fuses the data for them. If a satellite spots a vehicle and a drone spots a vehicle, Gotham's system understands it is the exact same physical object and assigns it a unified profile.
That is wild.
The real-world example of this is the U.S. Army's Project Titan.
Okay, what is that?
It's a modernization effort aimed at deep sensing and real-time targeting. In a modern war zone, the sheer volume of data pouring in from space, air, and ground sensors is completely beyond human processing capacity.
Right, there's just too much information. So Gotham acts as the processing engine, instantly cutting through the noise.
Yes.
It doesn't replace the commander. It just gives the commander a perfectly clear picture of reality so they can make a life or death decision in seconds rather than hours.
That speed is everything. It compresses the timeline from finding a target to actually taking action.
Wow.
Which brings us to the second platform. We are going to pivot from the chaos of a war zone to something that feels, well, completely mundane. The corporate supply chain.
Okay, a big shift.
Platform number 2 is called Foundry.
Yeah.
This is the commercial equivalent of Gotham.
Okay, I really have to push back here.
Go for it.
A military commander needs instant fusion of drone and satellite data because human lives are on the line. Why would a pharmacy or an airline need military-grade data fusion? It feels like using a supercomputer to balance a checkbook.
Honestly, I thought the exact same thing when I first looked at this.
Yeah.
But think about the data in your own workplace. Think about how hard it is just to find a single document or get 2 departments to share information.
Yeah, that's fair. It is always a mess.
Now look under the hood of a massive global corporation. Their data environment is just as chaotic, and in some ways even more fragmented than a military operation. Think about a company like Airbus.
The airline manufacturer.
Right, they build commercial airplanes. A single aircraft has millions of individual parts, sourced from thousands of different suppliers across dozens of countries.
Oh, wow. Okay, yeah. So if a supplier in one country has, like, a factory fire, it creates a massive cascading ripple effect.
A huge ripple effect. If Airbus uses traditional siloed software, figuring out the impact of that fire takes weeks.
Because everyone is disconnected.
Exactly. The procurement team has to manually call the supplier. The logistics team has to update the shipping timeline. The manufacturing floor has to recalculate their entire build schedule.
It is all manual.
It's entirely manual. And while they are figuring it out, multi-million-dollar planes are just sitting unfinished on the tarmac.
And Foundry comes in and builds that ontology you mentioned earlier. It maps the entire supply chain as a digital twin.
Yes. With Foundry, the system instantly sees the factory fire, cross-references it with the inventory in the warehouses, checks the manufacturing schedule, and immediately alerts the floor manager.
Like, hey, you are going to have a part shortage in 3 weeks.
Exactly. While simultaneously suggesting alternative suppliers.
That is crazy. It is the exact same pattern recognition logic used to track adversaries in Gotham, just applied to aerospace parts.
It really is. Another incredible example is Walgreens.
The pharmacy.
Yeah, they are a massive pharmacy chain with incredibly complex, shifting inventory demands. Think about cold and flu season. Demand spikes unpredictably by region.
Right, you need medicine in specific places at specific times.
Walgreens used Foundry to overhaul their entire data infrastructure and deploy artificial intelligence across 4,000 different physical stores.
Wait. Deploying a completely new software architecture across 4,000 retail locations?
Yep.
That would normally take a massive IT consultancy like 3 or 4 years.
Walgreens did it in 8 months.
Wait, really? How is that even possible? Implementing enterprise software is famously slow because you have to rip out the old legacy systems and train everyone on the new one.
That is the genius of Foundry. You don't have to rip out the old systems.
Oh, because of the universal translator thing.
Exactly. Because it acts as that universal translator, it just sits on top of whatever legacy databases you already have.
That is fascinating.
It connects to them, ingests the data, and builds the unified picture without forcing the company to delete their old software. That allows for incredibly rapid deployment.
Which I guess perfectly sets the stage for the massive technological shift we just experienced.
The AI boom.
Right. Companies finally got their data organized with Foundry, and then the generative AI boom happened.
Which leads us directly to platform number 3, AIP, the artificial intelligence platform, which launched in 2023.
Okay.
When ChatGPT and generative large language models hit the mainstream, every CEO in the world suddenly wanted the magic of an AI chatbot for their business.
Of course they did. But there is a massive structural flaw in how public AI models work for corporate use.
Oh, yeah.
If you want an AI to analyze your company's proprietary financial projections or your confidential customer data, you have to feed that data into the AI.
Which means employees were casually copy-pasting highly classified corporate secrets into public web browsers.
Which is a nightmare.
It was a massive compliance and security failure. You cannot hand your company's intellectual property over to a public algorithm.
No, definitely not. And the other problem is hallucination, right? Public AI models are trained on the open internet. If you ask a public AI, hey, how many widgets do we have in the Chicago warehouse? It doesn't actually know. It might just guess a number based on statistical probability because it literally doesn't have access to your live inventory system.
And this is exactly the twofold problem that AIP was built to solve. AIP allows a company to deploy powerful large language models directly into their own private data environment.
So it's completely internal.
It creates a completely secure walled garden. The AI operates strictly within your servers, and it never sends your data back out to the public internet.
But the real power comes from how AIP connects to Foundry or Gotham, right? Because an AI is only as smart as the information it can read.
This is the crucial point. If you buy a generic, off-the-shelf AI and point it at 50 disconnected, messy legacy databases, it is going to give you garbage answers.
Because it won't know which database is the accurate one.
Exactly.
Huh.
But Palantir already did the grueling work of building the ontology. They already translated the business into a perfect digital twin.
So when you ask the AIP chatbot a question, it isn't guessing based on internet training data. It is querying the perfectly organized ontology.
Exactly.
Right.
You can type into AIP, what is the most efficient way to reroute our logistics if the Port of Los Angeles shuts down tomorrow?
Wow.
And the AI will instantly calculate an accurate, actionable response because it perfectly understands your trucks, your suppliers, and your customers.
Okay, so this brings up an obvious question.
What's that?
If the recipe is simply, connect the data, build an ontology, and add a secure AI, why hasn't a trillion-dollar tech giant like Google, Microsoft, or Amazon just copied the blueprint?
Right.
They have unlimited capital and massive engineering armies. Why can't they just do this?
It is the ultimate question in tech right now, and the answer is that Palantir possesses a 20-year moat that simply cannot be replicated purely with money or code.
Really? 20 years?
Yeah, because building an ontology isn't just a software problem. It is a grueling, physical, human problem.
What do you mean by a physical problem? Software is just code.
Because legacy systems don't want to be integrated.
Oh, right.
For 20 years, Palantir has utilized a model involving forward-deployed software engineers. They don't just sit in a sleek office in California.
Okay.
They send their engineers physically out into the field. They sit in windowless rooms at classified military bases, untangling intelligence servers. They literally walk the floors of massive manufacturing plants, figuring out how a 20-year-old inventory scanner talks to a modern server.
So they've been physically untangling the friction of human institutions for 2 decades.
Yes. A major tech company can write an amazing AI algorithm today, but they do not have 20 years of institutional experience dealing with the bizarre edge cases, the broken legacy software, and the bureaucratic friction of hospitals and defense agencies.
That makes total sense.
Palantir has built calluses in the absolute hardest data environments on Earth. That head start is nearly impossible for a competitor to just close overnight.
When you look at the whole evolution from PayPal fraud to Gotham to Foundry and now AIP, it represents a massive shift in how organizations operate.
It does. And it leaves us with a fascinating reality to consider.
What's that?
Well, in the 20th century, power, both corporate and geopolitical, was largely defined by accumulation. The organization that could hoard the most information won.
Right. He who has the most data wins.
Exactly. But today, we are completely drowning in data. Hoarding it provides no advantage anymore. Power today is simply about who can connect the dots the fastest.
Wow.
The value isn't in generating more data. The value is entirely in finding the hidden patterns within the scattered data that already exists around you.
Which brings up some pretty heavy realities, honestly.
Definitely.
When you build a machine capable of connecting the dots at that speed and on a global scale, you are inevitably going to brush up against serious boundaries. Technology this powerful does not exist in a vacuum.
It doesn't. And that is exactly our next discussion. In part 2, we will look at the controversies that naturally follow this kind of capability.
Right, because there are a lot of them.
We will look at the highly debated contracts with ICE, the implications of using AI in military targeting workflows, and the massive ongoing debates surrounding data fusion and privacy. This is ELI5 Podcast. See you next time.